students, welcome back to our YouTube channel. Today we are going to discuss the past paper AQA GCSE and the paper held in June 2021, and the paper is higher tie. Okay, and the paper was paper 1. Okay, without wasting the time, we are going to solve the first question, and the question is about carbon and its compound. That fullerene is molecules of carbon and atoms. The first fullerene to be discovered was Buckminster fullerene, that is C60. What shape is the Buckminster fullerene molecule? So remember that the fullerene molecule is just like a spherical shape or ball shape. Okay, it's just like the shape of like the football shape. Okay, so here you have to write spherical. And the next one, give one use of the fullerene. That there are a lot of the uses of that molecule, but here you can write as act as a catalyst. Okay, and the second one you have to write here, that is also used as an antioxidant. Antioxidant. All right, now here the next question is propane is a compound of carbon, hydrogen and oxygen molecule. Here is the cross dot diagram of propanone molecule, and the question is complete fig 2 to show a propanone molecule, use line to represent each single bond. So here you can see that this one that is shown, and here you can see on both sides CH3 is present here. Okay, so it means you need to add CH3 on both sides here, just like this. Here is carbon, hydrogen, hydrogen, like this. Okay, and now here the next question, determine the molecular formula of propanone. So you can write as here CH3, COCH3, or you can write as a combined form like C3H6O. Okay, now the next one, that propanone is a liquid with a low boiling point. What does propanone have the low boiling point? So you know that the key point for the low boiling point, that is there will be like a weak intermolecular forces. So option D is correct. Okay, and next question is fig 3 represent the structure of graphite, and the graphite just like a layer structure. Explain why graphite is a good conductor, a good electrical conductor, and soft and slippery. The first point is very important, like why graphite is a good electrical conductor. Although you know that the graphite contain covalent bonding, and the graphite that has a giant macromolecular structure, but why graphite a good electrical conductor? Because of the graphite has delocalized electron. How? Because you know that carbon has ability to make 4 bonds, but in the graphite structure carbon will make 3 bonds and 1 electron that is present as a free electron, and because of that electron, the free electron that is present like a freely or delocalized electron, so because of that the graphite is a good electrical conductor. So you can write here because of delocalized electron. Okay, delocalized electron, the first one. And the second one, like why and the delocalized electron can move through the structure and carrying that electrical charge, so graphite conducts electricity. And the next one, why the graphite soft and slippery? Because here you can see here in the diagram, the graphite has a layered structure that contains layers. Okay, so you can indicate here that the hexagonal rings with a weak molecular forces between the layers and that contain a layer structure. So I'm going to indicate just like here, layer structure, but you have to write in detail because here that question is 6 marks, so you have to write in a detailed form. Okay, and next question is about atomic structure and the periodic table. Like gallium is an element that has two isotopes. What is the meaning of isotopes? You should answer in terms of subatomic particle. So that is very important. If you write here that has like same atomic number and but different atomic mass, but that answer will be wrong. Why? Because here the discussion is about the subatomic number. So you have to indicate here that the isotopes have same number of protons but different number of neutrons. Same number of protons but different number of neutrons. Okay, next question is the show like table 1 shows the mass numbers and the percentage abundance of the isotopes of gallium. Here are the mass number and the percentage abundance. Calculate the relative atomic mass of gallium. So you know that for the relative atomic mass you need to multiply the mass number by its percentage abundance and then you have to divide by 100. Like here is 60 times, like here the mass number is 69 plus the second one is 40 times 71 divided by 100, and when you calculate this the answer is 69.8. okay, and now here the next one 2.3 is gallium is in group 3. So if that is present in the group 3, give the number of electrons and neutrons in the atoms of isotopes 69, 31 gallium. So here by using the electronic configuration, the number of electrons that are 31 and the number of neutrons that should be here 38. Okay, next one is what is the most likely formula of the gallium ion? Because that is present in the group 3, so obviously the gallium will lose 3 electrons and get the positive 3 charge, so option 3 is correct, gallium plus 3 charge. Next is 2.5 is gallium was discovered 6 years after Mendeleev published in his periodic table. Give 2 reasons why the discovery of gallium helped Mendeleev's periodic table to become accepted. So the first one, that is the gallium fitted in the gap the Mendeleev had left. So that is fitted in gap, like which gap the Mendeleev had left, the first reason. Okay, and the second reason you have to write that the gallium properties were predicted correctly by Mendeleev's, or the properties of the gallium matched rest of the group. Okay, now here is the next question. This question is about the extraction of metals. Element R is the extracted form its ore by reduction with hydrogen. The equation for the reaction is 3H2O plus RO3 plus R, that gives R plus 3H2O. The sum of the relative formula mass of the reactant 3H2 plus RO3 is 150. Calculate the relative atomic mass of R. So you can find out the relative atomic mass by using the products or by using the reactants. For example, if we are going to use the reactants, then it would be RO3 plus 3H2O. It gives how much? 150. So here you have to write R plus 3 times the oxygen is 16, because you know that whenever you have to find the molecular mass of any like the compound, you have to add, like put the sign of addition here in between the elements, and plus 3 times and the what like H2, sorry, here that is 2 is equal to 150, and here is 6 plus 48 plus R is equal to 150, and then you have to subtract 48 and 6 from 150, so R is equal to 150 minus 48 plus 6, and that equal to R is equal to 96. Okay, so the answer is 96. Or you can use the products, like for example 3 moles of water molecule plus R, that also indicated the same thing. For example, here the R plus 3 times 18 is equal to 150, and here R is equal to 150 minus 54, that equal to 96. Okay, both ways are correct. Next is identify the element R. So you should use your answer to question 3.1, the periodic table. So you know that the element R, the like here the relative atomic mass is 96, and that will be molybdenum or MO. Okay, next is carbon is used to in the extract tin from the tin oxide. The equation here that shown, calculate the percentage economy for the extraction in this reaction. So first of all, for the percentage economy, you have to find first the total mass of the reactant, that is the desired product divided by the total mass of reactant. So the desired product is here 119, and the total mass of reactant, that would be 119 plus 32 because of like the oxygens, and plus 12. So the total will be, I'm going to calculate, that is 163. So times 100, because for the percentage, so that gives us 73%. Okay, next is tungsten is a metal. Tungsten is extracted from the tungsten ore WO3. All other solid products from the extraction method used to separate from the tungsten. And here the table shows the information about 3 possible methods to extract tungsten from the tungsten oxide. The first is by using the reactant carbon, the second is hydrogen, and the third one is iron. Okay, so here like evaluate the 3 possible methods for extracting tungsten from the tungsten oxide. So you can see here, first the carbon, that is relative cost of the reactant, that is low, so it means that, and iron is also low, so it means carbon and iron, that are the cheapest reactants. And the second one, The second is hydrogen is expensive reactant. Okay, and the second reason, like the method you have to write here, the first method, tungsten needs to be separated from the tungsten carbide. If here the tungsten carbide is present, you can see here, if the tungsten carbide is present, then the method 1, tungsten needs to be separated, and in which we have to take some tungsten is lost as a tungsten carbide, and the carbon dioxide produced will escape during this product. Here the tungsten, like the tungsten carbide, there is some carbon dioxide is also produced when we use the reactant carbon here. Okay, and in the method 2, you have to see here the solid tungsten that will show here by using the hydrogen, and along that, because here you know that is tungsten oxide, the like oxide form, so oxygen react with the hydrogen to make water molecule. Okay, like for example here we have WO3 plus, if we use carbon then it will make carbon dioxide. If we use here hydrogen then it will make water molecule, or the next one, if we use the another reactant iron, that it will make iron oxide. Okay, Fe2O3 or FeO. Okay, so these are the products along with the tungsten. Okay, so these are the points you have to remember and you have to mention in this question. Okay, next question is about group 1 element. Give two observation you could make with when a small piece of potassium is added to the water. So remember that when we add potassium, so potassium melt, okay, or potassium floats. Okay, and also like the second one, you have to write here that because you know that when we add potassium in the water it will make oxides, and that also produced by using the flame test, it will show a lilac color. Okay, a lilac flame, and like it also like shows fizzing reaction. Okay, and here you have to complete this equation. So as I already mentioned that it will make potassium hydroxide along with the gas, that is hydrogen gas. So you need to balance this, because you should balance this equation. Here we need 2 moles of potassium along with 2 moles of water molecule, that will make 2 moles of potassium hydroxide and hydrogen gas. Okay, and next is explain why the reactivity of elements changes during the, like when we going down the group. So because of the reactivity increases, the first you need to remember that the reactivity increases. Why? The reason is that because you know that when we move from top to bottom, the atomic size increases. So it means that the outer electron shell or the outer electron is further from the nucleus, goes far away from the nucleus. Okay, further from nucleus, the outer electrons. Okay, so what will happen? So there is a less attraction between the nucleus, less attraction between nucleus, okay, and the outer shell or outer electron. Okay, so what will happen when there will be a less attraction? So it means that will be more reactive and the atom loses an electron more easily. Loses electrons more easily. Okay. Next, sodium react with oxygen to produce ionic compound sodium oxide. Oxygen is in group 6 element. Draw a dot cross diagram to show that what happened when sodium oxide, like when atom of sodium and oxygen react to produce sodium oxide. So here you need to make a diagram. So first here you have to make the shell. For example, I'm going to make only the outermost shell, and like that contain, like for example here is the like sodium outermost shell that contain only one electron, and the second one here I'm going to make the oxygen, and that will make, that will contain 6 electron in the outermost shell. Okay, so it means oxygen needs 2 more electron to complete its octet. So it means here is another another sodium also react, also loses the electron, outer electron. So what will happen? Now the sodium contain its complete shell. So it means here I'm going to indicate like the final diagram look like this. Here now sodium contain 8 electron with the net positive charge is -2. Okay, I draw only the outer shell. Okay, and while the sodiums that contain the positive charge, okay, and you have to draw the shells as well. And here in this way you have to draw only 2 shells for both sodiums, 2 shells each. Okay, and the last shell contain 8 electrons because the final shell removed when they lose the electrons. Okay, and next, why is oxygen described as being reduced in this reaction between sodium and oxygen atom? Because you know that for the reduction, oxidation is loss of electron and reduction is gain of electron. So it means here in this case oxygen gain electron. Oxygen gain electrons. Alright. Next, explain why the sodium oxide has a high melting point. Because you know that that is a ionic compound that contain a that has a strong intermolecular forces, and there is needed for a large amount of energy to break. Amount of energy to break the bonds, because sodium that contain strong electrostatic force of attraction, okay, or ionic compound. Okay, now the next one, this question is about salts. Name the salt produced by the neutralization of hydrochloric acid with potassium hydroxide. So here you can write the equation, and from the equation you can sort out, like for example here I'm going to write it, the KOH react with HCl, it will form like the salt, that will be KCl plus H2O. Okay, so you have to write here the formula, or like the salt name, that is potassium chloride, or you can write as KCl. Okay, next question, write an ionic equation for the neutralization reaction of hydrochloric acid with the ionic equation. You don't need to write like the whole equation. Okay, and here the ions will be H positive plus OH negative, it will make H2O. And now the next one, that is soluble salts can be produced by reacting dilute HCl with an insoluble salt. Here that is copper, copper carbonate and copper oxides are insoluble salt. Which of these insoluble salts can be used to make copper salts by reacting solid with dilute HCl? And here remember that the copper carbonate and copper oxide, if we react copper carbonate and copper oxide with HCl, it will produce the soluble salt. It will produce like what? It will make a copper salt. Okay, so you don't need to write only copper. So here that will be copper carbonate and copper oxide. Okay, so which one? Option 3 is correct. Next question is, a student makes crystals of magnesium sulfate. Here this method, the complete method is mentioned. So give one reason for step 2, step 5 and step 6. Step 2 is warm the sulfuric acid. Step 5 is repeat step 3 and 4 until there is a magnesium oxide remaining in the beaker. And step 6 is like filter the mixture. Why the step 2? Because the step 2 is because for the warm up reaction to, why? Because to speed up the reaction. Warm here, okay, I'm going to erase, that is to speed up reaction. To speed up the reaction. Okay, and why the step 5? To make sure that all acids react. Make sure all acid reacts or react completely. So that's why here we have to repeat step 3 and step 4 until there is a magnesium oxide remaining in the beaker. That is completely used. Okay, and why the step 6? Step 6 is filter the mixture, because to remove the excess magnesium oxide or to remove impurity. To remove excess magnesium oxide. Okay, or magnesium oxide. Question number 5.5 is, how should the filter be evaporated gently in step 7? So as you know that by heating or by boiling. Water bath, using a boiling water bath and use an electrical heater, and then what will happen? That will be the filtrate be evaporated gently in the step 7. That is commonly as a water molecule. Okay, now here is question number 5.6. Iron chloride is produced by heating iron in chlorine gas. So here all the material is given. Calculate the volume of chlorine needed to react with 14 grams of iron. And here that the volume of 1 mole of gas is 24 decimeter cube. So first you need to find the moles of iron. N is equal to mass over molar mass. The mass is given 14 and the molar mass is 56, and you got here that is 0.25. Okay, by dividing it. And now you have to compare the molar ratio. The molar ratio of iron and chlorine is 2:3. So it means you need to multiply the moles of iron by 2 and divide it by 3 to get chlorine moles. Okay, and the chlorine moles will be, when you multiplied it and divide by 3, that will be 0.375. Okay, and for the volume of the chlorine you have to multiply with 1 mole of gas, that is 24 decimeter cube. So that would be here 0.375 times 24, that gives us 9.0 decimeter cube. So this question is about metals, and here like the table 3 is present, that is shown. Which substance could be a metal? So you know that the metal probably that is has high melting point, high boiling point, that conduct electricity, and that also conduct electricity in a liquid state. So it means that is option C is correct. So you have to click on option C. Okay. Now the next one, explain why alloys are harder than pure metal. So there are a lot of reasons, but you have to write that the atoms are not the same size. The atoms that are present in the alloy form, that are different size of atom. Different size of atoms. Okay. The second reason, what will happen when they have different size of atoms? So the layer is not like arranged there, that have been distorted, so that contain distorted layers. So it means there is a like there will be a need of great force to repel, or you can say that the layers slide over each other less easily than in the pure alloy or pure metal, sorry. So here is the layer sides over, layer side slide over less easily as compared to metal. Okay, and you know that how the alloy formation take place, by mixing of metal metal combination, by mixing of metal non metal combination as well. Okay. Next is, the student wants to compare the reactivity of an unknown metal Q with the zinc, and here all the information that is given. Describe a method the student could use to compare the reactivity of metal Q with the zinc. So use the method should give a valid result. So for comparing the reactivity, you have to measure the temperature, because the temperature, that is very important. Okay. So when measure the temperature change when each metal is added in the silver nitrate solution, because here that is present like a silver nitrate solution is present here. So whenever you have to add the metal in the silver nitrate solution, so it means here it will be, you need to measure the temperature change. So I'm going to write measure temperature change. Okay. And the next one, you need to check the same mass or moles. So it means that the greater the temperature change, because when the greater the temperature change, that will indicate the metal Q is more reactive. Okay. So again I'm going to repeat that when each metal is added in the silver nitrate solution that have same concentration or the volume of the solution, so if the change, and you have to measure the temperature change simultaneously for each metal, and when the indication is that the greater the temperature change, it means that will indicate the metal Q is more reactive. Okay. Now the question number 7 is, this question is about chemical reactions and electricity. Electrolysis and chemical cells both involve chemical reactions, and electricity. Explain the difference between the process in electrolysis and in the chemical cell. Remember that in the electrolysis, here that is uses electricity to produce chemical reaction, uses electricity to produce chemical reaction. Okay. While in the chemical cell, here use a chemical reaction to produce electricity. So here is use a chemical reaction to produce electricity. remember that here is actually both are opposite. In the electrolysis there is a use of electricity to produce chemical reaction, and in the chemical cell where the use of chemical reaction to produce electricity. Now question number 7.2 is a teacher demonstrate the electrolysis of molten lead bromide, and here I think you need to complete this equation, like you should balance the half equation. So here bromide ion you need to write here that is converted into bromine, and bromine should be like as diatomic form. Okay, Br here that is 2. Okay, and for need to balance this here you need to put 2 here. It means that there is the loss of 2 electrons. Alright, the next question is about two aqueous salt solutions are electrolyzed using the inert electrodes. Table 4, complete table 4 to show the products at each electrode. So remember that the salt solutions are copper nitrate and potassium iodide. Okay, and here the product are at positive electrode, that should be here the negative electrode is copper and the positive electrode here is oxygen. Okay, and same happening here in the potassium iodide, the iodine that is here iodine at positive electrode, while the negative electrode where the H2 hydrogen. Okay, so the next one here, some students investigated the electrolysis of copper nitrate solution using inert electrodes, and here the diagram is present and the information is given. So the question is, some of the copper produced did not stick to the negative electrode but fell to the bottom of the beaker. Suggest how the students could find the total mass of copper produced. So here the first, the filtration, like filtration, and you know that in the filtration filter the mixture, wash and dry the copper residue. So wash and dry the residue that is in the form of copper, and the next you need to add to the increase in the mass of electrode. How to weigh that residue or the copper collected, and then you need to add to the increase in the mass of electrode. Alright, now the next question is related to graph. Here is, how do the result in Fig 5 supports the conclusion that the total mass of the copper produced is directly proportional to time. So you can see here in the 7.5 there is a straight line indicated, that the copper produced is directly proportional to the line. So you can write here the straight line through the origin, straight line. Okay, next question, how do the results in Fig 5 supports the conclusion for the total mass of copper produced directly proportional to the current? Use data from Fig 5. In your answer you have to see here in the Fig 5 like 0.3 amperes. So the here the mass, the total mass of copper produced, that is normally about here is 0.07. Okay, and here you can see that that is going to be doubled. So it means for a given time when the current doubles, the mass doubles with the supporting data. So it means here you have to write when current double the mass also double. Okay, here is when. Okay, next question. Copper nitrate solution is blue. Suggest why the blue color of the copper nitrate solution fades during the electrolysis. So you know that because of the copper ions discharge. Copper ions discharge. So that's why the blue color also fade. Okay, from the solution. Next, here is like the numerical base. Determine the number of atoms of copper produced when copper nitrate solution is electrolysis for 20 minutes at the current of 0.6 ampere. So you need to check from the graph 20 minute and 0.6. So that is here, this one approximately 0.24. Okay, so here is you need to find the number of moles first. As you know that mole is equal to mass over molar mass. So N is equal to 0.24 divided by the copper atomic mass is 63.5, and you get the number of moles, that is equal to 0.00378. And now you have to apply the second formula to find the number of atoms, that is capital N, that is indicated the number of atom is equal to moles times Avogadro's number. Okay, moles times Avogadro's number. So here the moles are equal to 0.00378 times 6.02 10 to power 23, and when you multiply this, and here the answer will be number of atoms will equal to, it should be 3 significant figures, so that is 2.28 times 10 to power 21. Okay, now question number 8, that this question is about the reaction between the hydrogen sulfide and oxygen, H2S and oxygen. Okay, and here that what does the H2G represent? G means that is present as a vapor form. So here is water vapors. Okay, the next question, calculate the volume of the gas required to react with 50 centimeter cube of hydrogen sulfide. So here that would be like, again we already did the same type question in the previous like the questions, so you need to check out the procedure and for the calculation of the volume of the gas. So here I'm going to calculate, and that is first, like the 50 centimeter cube volume of the sulfuric acid is given. So by using the volume of the sulfuric acid and the molar ratios that are given here, the H2S and oxygen, by comparing you can easily find out the volume of the oxygen. So that is 75 centimeter cube. Okay, the next question here is like the energy diagram. You should complete the profile line, label the activation energy, label the overall energy change. So here is the fig 6. Now the reaction is exothermic. For the exothermic, the product should be below the reactants. Okay, so here it would be the products. Okay, and the activation energy, you can here label it. I'm going to, here is the activation energy. Okay, and the next one, that label the overall energy change. So you need to label the overall energy change drawn at the label like this. That is the energy change. Next question is about like fig 7 shows the displayed formula equation for the reaction of hydrogen sulfide. So 2H2S plus 3O2, it gives the 2 moles of water molecule and 2 mole of SO2. So here the bonds, like the bond energies are given. In the reaction, the energy released from a new bond is 1034 greater than the energy needed to break the existing bond. Calculate the bond energy X for SO bond. Okay, here you need to find out the sulfur oxygen bond energy. So as you know, here first you need to find the bond broken is equal to, that is, here you can see like HS. So there are 4 HS bond because 2 moles of HS2, like H2S, that contain like the 4 HS. So here you have to write 4 into 364 plus, and here the next one, that is 3 oxygens bond like 3O2. So it means here that should be 3 times 498. Okay, so bond broken, that will equal to 2950. Now the next you need to find the bond form energy. Bond formed. So here that will equal to like the bond broken plus the total energy that is given. So it means you need to write here 2950 plus here the new bond, that is 1034. You can sort out directly. I'm going to apply the direct method. So that is equal to 3984. Okay, now the next step is, here you can see that how much bond that are present in the SO. So there are the SO2 that contain 4 bonds. So here I'm going to write that 4 X plus, and the next there are 4 bonds of OH. So here you need to write 4 times, and the energy of OH, that is 464, and calculate this, is equal to this energy, that is 3984. Like first you need to multiply 464 times 4, that is 1856, and subtract it from 3984. Okay, and then divide by 4. So the answer will be, I'm going to calculate on the calculator, the answer is 532 kilojoule per mole. Okay, now the last question of this paper, that is, this question is about acids. Hydrogen chloride and ethanoic acids both dissolve in the water. All hydrogen chloride molecule ionize in the water. Approximately 1% of the ethanoic acid molecule ionize in water. The question is, a solution is made by dissolving 1 gram of HCl in 1 decimeter cube of water. Which is correct? The description of this solution, and that solution is about, you have to click which one. That is like the information is, a solution is made by dissolving 1 gram of HCl in 1 decimeter cube of water. So it means here, as you know that HCl is the strong acid, so it means that that will be like, you need to find whether it is concentrated or dilute. So there is 1 gram only in 1 decimeter cube, so here is a dilute solution of concentrated acid. Next question, which solution would have the lowest pH? So here is like 0.1 moles per decimeter cube, 0.1 mole per decimeter cube, or 1.0 decimeter cube of ethanoic acid solution, or 1.0 moles per decimeter cube of chloride solution. As we already discussed, that is in a diluted form. So it means here it will be number D. Okay, next question is about, like, suggest the 2 improvement to method that would increase the accuracy of the result. So here is the method that is given, and like here we have to read out, measure 25 centimeter cube of the sodium hydroxide solution into a conical flask using 25 centimeter cube pipette, and add 2 drops of indicator to the sodium hydroxide solution, fill the burette, and add the ethane dioic acid solution to the sodium hydroxide solution until the indicator color change. Read the burette to find the volume of ethane dioic acid solution used. Suggest to improvement to the method that would increase the accuracy of the result. So here you need to add drop wise ethane dioic acid. Okay, add drop wise. Okay, ethane dioic acid. Till like the end point, okay, near the end point. And the second one, there is no mean find, so it means you have to repeat the experiment, repeat and calculate mean. Okay, so the question number 4 is 9.4 is about, the ethane dioic acid is a solid at room temperature. Calculate the mass of ethane dioic acid needed to make 250 centimeter cube of a solution when concentration is 0.0480 moles per decimeter cube. Relative formula mass that is given. So here you need to first the concentration that will equal to the formula mass, that is here the concentration is equal to the formula mass, that is 90. Okay, I'm going to write it again. Here C is equal to 90 times, here the concentration, the pre-concentration that is given 0.0480. Okay, or in other way you need to find first moles. Okay, first of all I'm going to tell you this method and then we will solve the other one. So here you can get the concentration that is equal to 4.32. Okay, and then you need to, for the finding the mass is equal to the concentration that is 4.32 times the decimeter cube, that is like here is we have 250 centimeter cube, so you need to convert it like by multiplying 250 over 1000. Okay, so mass will equal to 1.08 grams. That is the one method. The second method in which you need to find first moles. So moles is equal to the concentration 0.480 times volume in decimeter cube, so 250 over 1000. Okay, so that is equal to here it would be equal to 0.012, that is the moles. Now here you need to multiply mass is equal to moles times molar mass, so moles equal to 0.012 times the molar mass is 90, and when you multiply it, so mass is equal to again 1.08 grams. Okay, so here mass is equal to 1.08 grams. In this case, here the mole is equal to concentration times volume, so volume should be in the decimeter cube, and then here you have like moles, and moles equal to moles times mass is equal to moles times molar mass, so that equal to 1.08. And here is the last question of this paper, that the student found that 25 centimeter cube of sodium hydroxide solution was neutralized by 15 centimeter cube of 0.0480 moles per decimeter cube of ethane dioic acid solution. The equation is given. Calculate the concentration of the sodium hydroxide solution in moles per decimeter cube. So first you need to find here the the moles of ethane dioic acid. So in 15 centimeter cube, you can see here like 15. So you need to first like change it into decimeter cube. Like for example here, moles of ethane dioic acid, that will equal to the volume time concentration or concentration time volume. So concentration is 0.0480 times 15 over 1000. Okay, and here you get 0.00072. These are the moles. Okay, and the next you need to find the moles of NaOH by comparing. You can see here like there is the ratio is 1:2. There are the 2 moles of NaOH and here is the 1 mole of ethane dioic acid. So it means here you need to multiply it by 2 to get the moles of NaOH. Okay, so that will equal to 0. Okay, I'm going to write this 0.0014. Okay, and now you just need to multiply these moles with here, that will equal to the concentration will equal to moles 0. The concentration is equal to volume over mole. So here I'm going to write like this 0.0144 over here that 25 centimeter cube is present, so here is 25 times 100. I just change it. So now the answer will be, by calculating it, so that is equal to 0.0576 moles per decimeter cube. So that is the answer. Okay, so that is the first way. The second way in which I am going to write again, so that is volume times the concentration of acid over volume times the concentration of base. Okay, and here the molar ratio is 1:2 and the acid is 1 and the base is 2. So here for the concentration of base, that is NaOH, here you need to write concentration of base is equal to here volume over, like the concentration here, that is go here, the volume over volume times concentration of acid. Okay, so you need to write here in this form, like 2 times 15. I just change it because here by dividing it 1000, so that's why 15.0 times 0.0480 over, because here I didn't, it just like 1 over 2, 1 over the concentration of base. Okay, so that is equal to, so you just when you like reverse it, so it means that the concentration of the base that will go into the denominator, and the next, like the whole term will be like the volume should be in the denominator and the volume and concentration of acid in the numerator, and that is also multiplied by like 2 that go into the numerator, like here I wrote, and divided by the volume is 25. Okay, so here the answer will equal to 0.0576 moles per decimeter cube. Okay, so that's all about the AQA paper 2022 higher tier, and if you like our video, kindly subscribe our channel and share this video. Okay, in the next video we will discuss the next paper, so take care, we'll see you in the next video.